All right, let's get started. Sorry for the delayed start. So I'm Andy Ritger. I work at NVIDIA. I'm going to talk a little bit about our proposal for a new updated Linux OpenGL ABI. This slide deck will largely be a rehash of last year. I'll start by covering the overview of what I described last year. But then from there, I'll also go into what progress has been made in the past year. And I guess to talk a little bit about what this is. So we're proposing a new ABI that would both define a new ABI between applications and OpenGL libraries, and then also the ABI between vendor-neutral OpenGL libraries and then driver implementations. And this would allow multiple vendor implementations to coexist, so finally get rid of the conflicting libgl.so problem. So coexisting on the file system, coexisting within the same process. Ideally, you'd be able to have multiple GPUs and multiple OpenGL implementations loaded into the same process and be able to render to those separate GPUs within the same application. And the focus of this is Linux, but I don't think there's anything here that really limits it to Linux, so hopefully this would be applicable across other Unix and Unix-like platforms. Okay, so the libraries involved. So first there's a set of vendor-neutral libraries that aren't provided by any particular OpenGL implementation. So these would be the front-end libraries that provide the symbols that the application links against. So this would be libOpenGL, and then libgles. There would be vendor-neutral window system libraries, libglx and libegl. And then vendors would provide their implementations of libglx and libegl. So for the in EGL specification terms, it's called the client API. Client API here means OpenGL or OpenGLES. So libOpenGL would provide, we kind of just need to pick, somewhat arbitrarily, what set of OpenGL entry points libOpenGL will provide. That doesn't make any guarantees about, what OpenGL versions the vendors need to support, but we just need to pick a set of symbols. OpenGL 4.4 was the latest as of last year when I presented these slides, so we could stick with that, or we can move to OpenGL 4.5. I don't think.
Fewer DL sims we have to do, the better.
True. Okay. So we'll bump this up to OpenGL 4.5, and let's see here, and then additional entry points can be provided by the vendor registering additional things, and then applications getting it through get-proc-address. Let's see here. And libOpenGL should not provide any window system entry points, so nothing EGL or GLX in libOpenGL. It's really intended to be independent of any particular window system or window system binding. And then the comparable for the GLES vendor-neutral libraries. For the window system libraries, libegl and libglx, that's a capital GLX, not to be confused by the libglx in the server. These would provide, well, for libegl, here again, the latest as of last year was EGL 1.4. EGL 1.5 is released, but we can, again, somewhat arbitrarily, but I think it is a good policy that pick the most recent EGL version and a reasonable set of extensions to minimize how much applications need to get proc address. But we pick a set of symbols that libegl provides, and then that's what's provided. And the libegl and libglx vendor-neutral libraries would be responsible for selecting and loading the vendor implementation. So now the interesting part is the vendor libraries that get loaded by libegl and libglx. So there would be some initialization function. So as an example, libglx selects the right vendor library, it loads it. The vendor library then executes some initialization. And then that would pull along the vendor's implementation of the of OpenGL and OpenGL ES. So in this proposal, there's no lib OpenGL vendor. The vendor piece is, at least in terms of the interface between the vendor-neutral libraries and the vendor-specific libraries, that interface is encapsulated in libEGL and libGLX vendor. So then the vendor library would register with the appropriate client libraries at make current time, and then at that point the dispatch table for all of the OpenGL or OpenGL ES entry points get plugged in. And to avoid any sort of name collisions, we can define some simple rules around not providing any exporting any symbols from the vendor libraries that that collide with the namespace of what the vendor-neutral libraries are supposed to provide. So the interesting problem with this is how to actually do the dispatching and how to figure out which vendor implementation to dispatch to. So that's pretty easy for the client APIs. Once you've made current, you've defined you've got a context, you know what you're talking to, and so everything thread local, we know which vendor. And so at make current time, you plug in your dispatch table, and then the vendor in question is easy in that case. It's harder for the Windows System APIs. Most of the Windows System APIs fall into one of several categories. Many of the entry points imply a vendor by their arguments. In the case of GLX, they may either explicitly specify an X screen, or they may specify a resource like a drawable or a context or something else that was created with respect to an X screen. So in most cases, we can infer the vendor, in the case of GLX, by the arguments that were passed in. Let's see here. Some Windows System entry points operate on the current context, and so that falls into the same category as the client APIs in terms of we're made current to this context with this vendor, and then Windows System entry points that operate on the current context dispatch naturally in that case. And then some Windows System entry points return current API state, like get current context. And in that case, I think the only option is for the vendor-neutral library to track the API calls well enough to be able to satisfy those entry points itself. But I guess the point here is that in nearly all cases, when the vendor-neutral libraries need to dispatch to a vendor, it's pretty clear who the vendor should be. And then I guess this last point is sort of interesting. We've designed this mostly from the application client side of things, but we're not trying to address server-side GLX. NVIDIA, AMD, and Mesa all provide independent GLX extension implementations, and those. Yeah, but those extensions obviously are server-wide, so they can't currently coexist. We could probably construct some scheme to dispatch server-side, but given where we're going, it's probably not worth the effort as we migrate from GLX to EGL. So if we decide that that's useful to do, we can solve server-side GLX dispatching, but I think solving the rest of this we'll have a lot of benefits in and of itself. Okay, and so here's an example of the theoretical flow of things. So an application would call any GLX entry point. So that would call into libglx.so. Libglx.so would query the X server somehow to determine for the screen that was specified in that entry point which vendor is driving that X screen. So then once we know which vendor we're talking about, then we load that vendor's libglx implementation and then dispatch from there for all the subsequent GLX entry points that talk to that vendor. Then when the application calls GLX make current, that gets passed through like anything else, any other GLX entry point, make current gets passed through to the vendor, and then that's the point when the vendor calls back to the to lib OpenGL to register a dispatch table. And then after that, all of the OpenGL calls get dispatched through that dispatch table. Yes. And libEGL is the same. The only sticky point there is that it's a little less clear how to make the initial selection about which vendor to map to. So I think we'll have to work out the correct heuristics there. But otherwise, the flow and the interaction between libEGL, libEGL vendor, and lib OpenGL is the same as in the previous slide. And then for backwards compatibility, the goal is that existing applications don't require any changes and are really transparent, or that this change is transparent to existing applications. So to provide backwards compatibility, we'd implement a vendor-neutral libgl.so.1 that would basically take the union of all the entry points that.
And you couldn't just export all of the symbols that are exported into the OpenGL.
Exactly. Yes.
Just take all of the symbols and defining something.
Well, I don't know if all the symbols that would be in lib OpenGL would be everything that's provided by all the symbols provided today by all the different libgl.sos. So
it would be, if you're talking about just if you're in the services of OpenGL 4.5, there are others.
Yeah, everyone exposes, either intentionally or accidentally exposes a lot of like vendor extension functions that shouldn't be come directly out of the library.
yeah, so I think to make this as painless as possible for existing applications, we'd take AMD, Mesa, NVIDIA, and anyone else, take the union of all those symbols. That's what this new vendor-neutral libGL needs to export. Now, for all the symbols that do map directly to things in lib OpenGL, then just ELF filter through to those. For the rest, the vendor-specific extension entry points and things like that, in the vendor-neutral libGL, that would have to get proc address to get the right thing to call to.
You can actually do some fun kludges.
You can actually do some fun kludges, assuming that the application is going to DLSIM or link to those. You can actually do fun kludges to forward those through, just like the ELF filter stuff. There is
Sure.
magic available.
Yep. Yeah. There's definitely a lot of ELF magic
So you
available.
don't actually have to the goal is to not thunk through this library.
Yes, ideally.
Yeah, and it's definitely possible.
Yeah. Okay. Alex has a question or comment.
So I apologize for not mentioning this earlier, but DT filter is not going to work with glibc because glibc has a fake implementation of DT filter that won't do what you want. So yes,
we found at least one bug with the DT filter implementation. Yeah. But I mean, so far it looks like that's just a bug. At least the bug that we saw was that if you have a shared library that has a DT filter reference on another shared library, and if that other shared library has a constructor, then when you DL open the first shared library, then the loader crashes. But otherwise, we saw filtering work properly and resolve symbols the way that you'd want. Are you aware of something else?
it shouldn't work when the application is using DLSIM to look up OpenGL symbols, because then DLSIM is going to use the wrong shared object. They just won't find what you want.
And then would return null, or?
That's the reverse of my experience. What you would occasionally hope for DT filter is that when your filter object, its list of undefined symbols would be provided by the filtee, and they will. If you DL open the libgl in this instance and try to DLSIM for something in it that isn't in its undefined symbol list, it will also still find it in the filtee object. glibc will find more things than you want, which is probably okay in this situation, but the bug you're describing is the reverse of the bug I hit.
Yeah. So I mean, Yeah,
But if what this requires is a glibc that doesn't suck, that's fine with me too. Like I'm willing to fix glibc.
Yeah. So I mean, yeah, we can fix issues in the loader if there are problems there. If it's not workable for some other reason, I think we have a variety of options for how we can implement libgl.so. But ultimately, the idea is that libgl.so would somehow pass things through to get to the real implementation that is in the vendor-specific libraries that's been passed through OpenGL to libgl.
Yeah, the one thing I might be concerned about is if you're trying to apply this to Android, I don't know how good of an ELF implementation Bionic has.
Yeah, I think Android's outside of the scope of this.
Okay.
Yeah, the Android guys have their own ICD model, and I wouldn't try to.
Okay, and in that case, yeah, this seems fine to me.
Yeah. Okay, good. Let's see. Yeah, and I guess it's important to note that libgl today provides not only OpenGL entry points, but GLX entry points. So this compatibility libgl would have to pass through, in addition to the union of all OpenGL symbols that are exported by any of the vendors today, it would also have to provide the union of GLX symbols that are provided by any of the vendors today. And again, the goal really is for this to be transparent to applications. Okay, so I presented that much last year, and we had comparable kinds of conversations, and it sounds like this is the right direction to go. So one of the other engineers at NVIDIA, Brian Nguyen, has been doing a lot of the implementation work. He had some other tasks that allowed him to not make as much progress as he would have liked, but we do have a basic implementation of this available now. So I'll spend a few slides talking about what's in that. The flowcharts I had before were a little bit more theory. And in practice, when Brian sat down to implement this, I guess this chart is mostly the same as what I described earlier. The one interesting new piece is the libgl dispatch shared object. But other than that, the application calls libOpenGL and libglx, or it calls around to the compatibility libgl, and then hopefully using ELF filtering or whatever kind of ELF magic, the symbols in libgl get routed. The symbols in libgl and libOpenGL get routed through to libgl dispatch. But otherwise, this is the same flow as what I described earlier. And in the next slide, we'll talk about what GL dispatch is. So this shared object implements the core of the OpenGL dispatching and manages thread local storage. It's based on GL API that Brian took from the Mesa implementation. Dispatch table management. It does a bunch of handshaking with the vendor implementation to get all of the function addresses, and then tracks make currents and updating dispatch tables in response to that. It is a shared library rather than being statically linked into libglx, so that it can so that we can have one instance of that shared library in the case that both libglx and libegl are in the same process. Adam?
I think it has to be shared in that part of the reason why we had GL API was to get the dispatch table to be the same between GL and GLES contexts.
Right. Yeah. Yes. So this follows the same model as that.
I'm going to keep talking.
But it's an implementation detail, or at least it's not application visible. So as part of Brian's work, he also yes. Why?
Because libOpenGL implements the entire desktop GL API, and you want libglappy to be the dispatch table for GLES without having desktop loaded. Like, this is just the dispatch table wrapper. This is exactly the same as what Mesa's libglappy is today, with a little bit more to do the vendor lookup stuff.
But we don't like libglappy because it's an extra function call.
Tough. Like, I'm sorry that you don't like it, but it's mandatory. If you're going to have both desktop and GLES contexts in the same EGL application, you gotta have it.
Yeah.
And that's a thing.
And it
that's
doesn't have to be an extra level of indirection. I mean, it gives you a way to manage dispatch tables that you can, that the entry points from OpenGL and OpenGL can jump through.
So libopenGL is essentially going to thunk through using elf magic into
Yeah.
libgl dispatch.
It's going to do the same thing that libgl does today, which is that the entry point, for all the GL entry points, the first step is call the GLAPI context lookup function to get the current context, get the current dispatch table, and jump into it. It's exactly what libgl does today.
Yeah. And Brian has spent some time optimizing this. He wants to look at it a little bit more, but I mean, particularly for some workstation benchmarks, we're very sensitive to API call overhead. And so, yeah, so we don't want this to be any more heavyweight than anyone else does.
So if this is any slower than the current NVIDIA libgl solution, this is not acceptable to you?
Correct.
Awesome.
Yeah. Yeah.
Your stuff is faster than Mesa today, so.
I know.
It's very
So
much.
this should improve life for Mesa.
Yes, hopefully.
Okay, good.
Yeah. Okay, so Brian hacked together an X extension to do mappings between, and here I'll have to defer the details to him. I've not looked at the code very closely in terms of what object he's mapping from to get vendor. I think this has to do with, given an XID for, let's say a drawable, which screen is that on, so that we know which vendor to load. So I'll just point to the code in this case. But I guess the belief was we needed something server side to be able to track that resource to screen mapping.
Yep.
And so I think when we get a little bit further into this, we'll have to have some discussion about should this just be a new extension that that gets built into the X server, or the right way to deploy this piece.
Well, this is something that DRI3 does today,
Okay.
right? DRI3, you handle the screen and potentially a file descriptor for a device that talks to the appropriate.
Underlying kernel infrastructure. Right, so that's what DRI3 has a
Yeah.
way of getting you a file descriptor back. And then
Okay.
you can do whatever you want with that file descriptor to figure out which GL driver to talk, which vendor that is.
Yeah. Yeah. I don't know if a file descriptor is the right thing that
It
we
was
want.
sufficient for DRI3.
Sure.
And that it gives you a file descriptor to a kernel device, and you can
Yeah.
do whatever ioctls you want on that kernel device to figure out what's going on.
So
in particular, we have a way of getting a PCI ID for that file descriptor.
Okay.
I mean, yeah, but if you're talking about handing back a file descriptor that could point to dev DRI card 0 or dev NVIDIA 0, which ioctl do you think you're going to call first?
All of them.
All of them.
Yeah.
Well,
Or
in-
you could just like ask the screen and get the same information in.
Yeah.
Yeah, but
in-
what
in
what
one
information do you provide back? You provide a string?
Well, yes, because that's the thing you need. The thing you need back is the string that is dollar curly brace vendor close curly in the model here. That
And
the string is the thing you want.
Why
yes.
am I putting that in the X server? Right now, that's what DRI2 does today. DRI2 returns a string back to the user and says, this is a driver you want to use, which is crazy, because what do you do for an NVIDIA chip? We return some random string, and oh, by the way, the user actually wanted to use Nouveau
Right.
today. How do we know?
Yeah.
Well, the way that we know is the kernel driver that's loaded is the DRM driver, so we know we want to use Nouveau.
Yeah. But so this may not completely gel with the glamour approach of one server side piece for all hardware. But in the current model where we have different server side X drivers, like the X driver that we have server side for that X screen has a corresponding vendor OpenGL implementation that we want to use.
Right, which is why having the file descriptor get passed back means that the driver has opened the appropriate kernel device, and so when you get that back on the other side, you have an actual PCI ID that you can get out of the file descriptor, and then you can use that PCI ID to figure out which drivers might be under that, and use ioctls on those drivers to figure out what's going on.
Why are you saying driver, Keith?
Kernel driver.
Why are you saying driver, Keith? We're not asking about the kernel driver. We're asking about what vendor library to dispatch into.
The kernel driver that's underneath the device defines which vendor library is going to be loaded.
That's only true That's just not true because libglx underscore Mesa is what we're going to have here. It's not going to be libglx underscore Radeon.
Why not?
Why would you?
Because I can avoid some additional shared library adventures.
I don't think the model precludes.
Well, this is a detail. But I still think you're wrong.
Yeah. So I admit that I was expecting the. So I admit I was expecting the vendor in this case to be NVIDIA, AMD, Mesa rather than something more fine-grained than Mesa. But I don't think the model precludes doing something more fine-grained. So I think we'd have options there.
I guess what I most would want to see if we were going to do this as an extension is just to make it a GLX extension sitting alongside like GLX Mesa query renderer.
Yeah.
Rather than taking up another X dispatch slot. But other than that, it seems fine.
Yeah. So I think the rest is implementation details. And yeah, I mean, I think we can make a file descriptor work. We can make a string work. So I think there are options there. And so this gets more into the details. And we can hash that out during review of the code. Again, here's the link to where the current implementation is. So far it's hobbling along. We have some unit tests that we've run against it, and we've hacked up the NVIDIA driver to be able to plug into this, and then then found some problems and started debugging those. So that's in progress. It's far enough along that if others wanted to try to plug other OpenGL implementations into this, you could start experimenting with it. So some of the existing issues we have, there's the ELF filtering bug that I mentioned earlier. We'll just have to go work that out. It's certainly not optimal in the way that when building the dispatch table, the vendor neutral library calls the vendor each time. So we need to make that better. And there's some memory management and leaks and out-of-memory handling that we need to fix. So some next steps. We'll run this library through a bunch of other use cases, interaction with multi-threading, with fork recovery, with loading and unloading, and all those sorts of fun shared library interactions. So we'll hammer on that and try to fix the bugs we find with that. We'll start a new thread on the Mesa development list to try to solicit some feedback there. So far, we've only implemented libopenGL and libglx. So one of Brian's next pieces is going to be the libegl piece. And as when we get into my next talk, we'll see there's probably some more things in EGL that will need to be in the vendor neutral library that span across any individual vendor. And we'll talk about the EGL device extensions later. And yeah, I think it's far enough along for other people to start experimenting with. So a few people over this XDC have asked me, what the migration plan is for this. I don't think we have, at least from NVIDIA's side, we don't have a firm deadline. But it'd be nice to start moving on this. So, given that we're as far along as we are, I guess it's probably most likely that NVIDIA would deploy this first, and by deploy I mean update the NVIDIA driver such that our implementation requires these vendor-neutral libraries, and then update our installation tool such that we include a snapshot of the vendor-neutral libraries, and if at install time we don't see those on the system, then put them in place, and then from the NVIDIA driver standpoint, whether the distro provided them or the NVIDIA installer did, we wouldn't really care, and hopefully I guess once more of the ecosystem comes up around it, then NVIDIA's snapshot of these libraries wouldn't be used. And I think doing it that way will also get some broader testing, and we probably want a few release cycles with that to get some exercise and shake out bugs before we nail down the ABI between the vendor neutral libraries and the vendor specific drivers. Yeah, so we'll keep working on that, and as time permits, if Mesa and AMD and whomever else can take a look and experiment with it and provide feedback. And so once we get further along and we have some confidence, then establish an ABI, and then do ABI versioning from there. And then once everybody's happy, then we'd encourage distros to start packaging and distributing the vendor neutral libraries. And I'm sure on Mesa's side, you guys will have a bunch of issues to work out in terms of, at some point you flip a switch and, Mesa requires the vendor neutral libraries to be there, or if it's a compile time thing, but I'm sure you guys can work that out. So a big thank you to Brian Wynn, who's been doing most of the implementation work on this. So you can contact him directly. He'll start a new thread on Mesa, excuse me, on Mesa Devel soon, and you can chime in there. And then here's some links where you can find out more. These slides and last year's slides, and then the original text document proposal, and then the implementation so far. So that's all I have on these slides. Any other questions or comments? Adam? Thinking.
So you can do get proc address before you have a context.
Yeah.
And if you do that on a GLX symbol,
Yes.
whose do you pick?
Yeah. So I guess to answer the easier version of that question, if it's a GL symbol, what we talked about last year was basically any get proc address on any string has to return a function pointer. So online generate, reserve some space for code and return a pointer to that, such that later on at make current time, when the dispatch tables get resolved, the memory that we reserve for that function pointer can get populated if the vendor has an implementation of that function. And then, then the app has that pointer and jumps through it, and that much can be made to work. For that's easy because the vendor is selected at make current time. For GLX functions, where normally the vendor is selected by by manual C code that has to go inspect the arguments of the function to decide who's to go to. That's harder to do with just generating some code and returning a function pointer and then later. So the idea there, and I'd have to look at what Brian's implemented so far for that, but the proposal was that whenever a vendor provides a GLX function that's beyond the core set that the vendor neutral library provides, the vendor has to provide two functions, both a vendor implementation of that function and a function that knows how to interpret the arguments and choose the right vendor. So then the answer to your question would be, it doesn't matter which vendor we choose.
Okay.
And there's lots of details there, and Brian's worked on that some, so I'll defer to the code.
I have it built. I just haven't read it yet.
Yeah.
I guess, okay, so the other question I had was, where would I find a copy of the NVIDIA driver built for this model? Because it would be nice to be able to see an example of that driver built for this model so that I can inspect what you're providing and whether that, so that I know,
Sure.
Okay, if I'm going to mutate Mesa into that.
Yeah, we've not released anything there. I'm sure we could do a one-off release is not something we recommend to customers, but for anyone who wants to experiment, here's a snapshot. So yeah, we can make that happen.
I don't even want to run it. I just want to run NM against it.
Okay. So I mean, I'm sure Brian could just send you an NM of it. So
Okay.
if that
That'd probably be good. I think that this is also a question that I could probably figure out once I've read the source sufficiently to see how you're doing symbol lookup. Part of the question is if you're libgl x_beza.so can't export symbols that conflict with the global namespace, how do you DL open it? Or do you must be DL opening it.
Yeah.
What do you DL sim out of it to get resolve functions out of it? How does get proc address look there?
I think there's some initializer function. So whether it's just a constructor, or there's something with a an established name that you DLSim when the vendor neutral library DLSims right after DL opens it to call to initialize things and go register. But yeah, I don't know the details offhand.
Okay.
And one for me.
Yeah.
So you say take code up how you get the vendor name, etc. aside. But at which point do you choose the particular vendor? So obviously you say that at make current you select it, but when do you actually establish who it is?
For GLX, I think it's relatively straightforward. It's whatever driver is driving the X screen, that implies the OpenGL vendor to use for anything we're doing with that X screen. So the GLX case, I think, is relatively straightforward. The EGL case, I agree, is a little less defined. So I don't know if you guys have comments on how have you dealt with that in Mesa?
A sort of similar question, but maybe this is a better one to punt off to the ATI people. But so with AMD running both drivers, both user space drivers on top of the same hardware driver, it's perfectly possible to have the open source user space driver driving X and the closed source user space driver driving your game. So how do we fit that into the system?
I don't think that's the case.
Yeah, I'll defer to Alex. And I don't know, maybe that's not fair. I don't know if Alex has had time to think about this at all.
Well, this is why I want something that doesn't identify which driver to use coming out of X, so that we can have that configuration resolved in the GL on the GL side.
Okay.
So you get some idea what the hardware is, and then
Yeah.
user space gets to decide what driver runs that.
Okay.
So that's why DRI3 uses a file descriptor, for instance,
Okay.
which was sufficient for my environment. It may not be sufficient for this other environment. Maybe just a PCI ID or something. I don't know.
Sure. Okay.
A file descriptor was sufficient to construct a PCI ID
Yeah.
on the client side,
Yeah.
and I needed a file descriptor anyhow.
Okay. Any other comments? Yes. Pass the microphone down front.
So you have found some bugs in glibc related to the symbol filters.
Yes.
And you said that your proposal applies not only to Linux but also to other Unix systems, for example, FreeBSD. Have you tested whether their implementations of libc also have bugs that impede your progress?
That's a very good question. I've not tested any of that extensively. I know a year or two ago when we were starting to float the proposal, I put together some hacks and ran it at least on FreeBSD and Solaris, and had I think pretty successful results there. But it definitely wasn't exhaustive. Like I didn't trigger the particular glibc bug that we found now when I was doing that testing 2 years ago. So no, there may be problems on other platforms. There may be platforms that don't implement ELF filtering at all. And I guess it would be unfortunate to make that a requirement of this. And so if it comes down to it, maybe we can find a different way for these front-end libraries to pass things through.
Yeah, I mean, the filtering concept was born of Solaris. So I think
Yeah.
if we're kind of limiting the scope of this to Solaris like ELF, and then if you manage to rise to that level of ELF implementation, then this is an ABI that your application can consume that will make your users' lives easier.
Yeah.
That's a reasonable way to approach it, I think. And if your BSD or BOS or whatever doesn't happen to implement that bit of symbol filtering, okay, well, you can continue to copy the Linux ABI, the version 1.
Yeah. I mean, really, the ELF filtering, I think, is a cool implementation detail. And I mean, the high level, like the, yeah, we'd have to try it. Yeah, so I don't think the ABI proposal necessarily depends on L-filtering. I think it's a neat way to solve some of the implementation details, but I don't think it would be a strict requirement. Maybe a strict requirement to have a fully performant implementation. I mean, worst case, you could have an extra level of indirection to jump through, which would be better than not working, but not as good as not being as fast. Not as, never mind. Okay, any other comments or questions for now? Okay, good. Thanks. Okay, so I have my second talk is about NVIDIA's work towards supporting Wayland and other compositing systems. Do we take a